Consider the tightrope artist when you're solving an equation. Someone who knows a little bit more about math than you might think. He or she has to keep their center of mass directly over the rope to stay balanced. If you're walking across a tightrope and you move even a little bit off the center, the rope begins to swing back and forth like a pendulum. Then you start rocking back and forth as well, and eventually you fall down. But if you can respect the concept of balance and even distribution of weight, then you can walk across that tightrope just as you can solve a basic algebra equation. Notice that every step of the way, he has to make sure his weight is evenly distributed so that he can solve his problem of getting to the other end of the rope. If at any point he starts to forget this concept, he needs to regain his balance before he continues on. So we just saw our expert tightrope artist walking across this rope with a lot of grace and poise and equilibrium, taking very small steps along the way and staying in balance as opposed to taking very large steps and going out of balance. We're going to do the same thing now with this problem. We're going to say, we're going to take a look at this problem here, which is -4 times a plus 6 plus 5 times a minus 3 in parentheses equals 3 times a minus 1. And we're going to think about the principles of balance and equilibrium that the tightrope artist uses, and we're going to apply it to this problem. So we're going to start off with -4 times a. Here we're going to distribute the -4 times a and distribute the -4 times 6, and we get -4a plus minus 24. We have a negative times a positive, we get minus 24. And then we have 5a here. We distribute the 5 to these two terms here in the parentheses. 5 times a is positive 5a, and 5 times -3 is minus 15. And one thing we're going to do here is I've seen many students over the years oftentimes draw this little line. They have teachers say, draw this tightrope line across down the middle. They don't always call it a tightrope line, but that's essentially what they're trying to say. This side here has to equal this side. And so this is to help people remind. Some people like to do this. A quick note, drawing a line down the middle of your equation like this is not something you're going to see in a textbook. Some teachers like this approach, others don't. Keep this in mind as you're working these kinds of problems. So 3 times a, and we get 3a. And 3 times -1, we get -3. So we have this side here equals this side. Okay? And here's our tightrope down the middle. We got to make sure this side equals this side. Now we're going to continue on, and we've got our -4 here, a, and we have a 5a. So we're going to collect these common terms. We're going to say -4a plus 5a makes a, and we have -24 minus 15, and we'll just do some side work over here. -24 minus 15, 4 and 5 is 9, 2 and 1 is 3. If we have 24 negatives and 15 negatives, we get 39 negatives. So we get -39 minus 39, and this equals 3a minus 3. And again, we're taking our small steps along the way. We're still in balance. We're respecting that law of keeping things in balance. And now we have a minus 39, 3a minus 3. So I'm going to take a small step here and say, let's get rid of this 3. So I have plus 3 here. And so I don't fall off my tightrope, I'm going to plus 3 over here. So now this goes away. -3 plus 3 becomes 0. So I can cross that off. And all I have left here on the right side of the equal sign is 3a. And then I have here on this side, -39 plus 3 makes -36. And I have the a comes down as well. Because there's no other a terms, I'm adding and subtracting, so I bring the a right down. Now I have a minus 36 equals 3a. Now I'm going to collect the a term. I have an a term here and a terms here, so I'm going to say, you know what, I'm going to minus a here. And to stay in equilibrium, stay in balance, I'm going to subtract a there. Goes away. Now I have minus 36 equals 2a. And now, last thing I have to do here, I have the 2 and this is 2 times a. The 2 and the a are connected by multiplication. I want to unlock this. To unlock multiplication, I have to do the opposite of multiplication, which is division. So I'm going to divide by 2 here and divide by 2 here. And now this goes away. This becomes 2 over 2, which is just 1. So this is literally, you can rewrite this if you want as 1a equaling negative 36 divided by 2, which is negative 18. And then 1a is really just a, so I can say a equals negative 18. Again, you could write 1a, but typically it's written as a. So there's our answer there. Negative 18 equals a. So we have our solution here, a equals negative 18, and now we want to verify that the solution works. So we've written our equation down, and we put a little question mark above the equal sign because we're not sure if a equals negative 18 is the solution for this equation. So we're going to figure that out by replacing each of these three a values with a negative 18 on each side. After we do that, we're going to simplify the left side here, then we're going to simplify the right side. And if the left side ends up equaling the right side, if we're in balance, then we know we have a solution. So let's go ahead and do that. We have negative 4, and this a becomes negative 18, plus 6, plus 5 times, and we have negative 18 here, minus 3. Again, the a gets replaced with negative 18 here, and the a gets replaced with negative 18 here, because a equals negative 18 is the solution that we're testing. Does that equal, and we put a little question mark again because we're not sure, 3 times negative 18 minus 1. Again, a equals negative 18 because negative 18 is equal to a according to our solution. And now we go to the next line. We simplify what's inside the parentheses because the order of operation tells us that's what to do next. So we say negative 4 times negative 18 plus 6 is negative 12. Plus 5 times negative 18 minus 3 is negative 21. Does that equal 3 times negative 18 minus 1, which is negative 19? Now, what do we do next? Let's see. Negative 4 times negative 12, that's going to make a positive 48. 5 times negative 21 makes a negative 105. Does that equal 3 times negative 19, which is negative 57. So one more calculation here. If 48 minus 105 equals negative 57, then we have a winner. Let's see. 48, this is a positive 48. This is a negative 145 that we're combining. There's more negatives than positives in this case, so we're going to have a negative answer. And what do? We take 105. We'll do some side work here. 105 minus 48. And 5 minus 8 we can't do, so we're going to borrow here. This becomes 0, this becomes 9, this becomes 1. I know I'm going fast, but I'm assuming if you're watching an algebra video that you know how to add and subtract integers. If not, check out one of my videos that show you how to add and subtract integers. So 15 minus 8 is 7, 9 minus 4 is 5, and we have a negative 57. Again, we have a negative here because we're combining 48 and 105, and there's more negatives than positives, so we have a minus here. And that, in fact, does equal negative 57. So we have a solution, a equals negative 18. If you have any questions or comments, please feel free to leave them in the comment section. And please subscribe to our channel. Thanks a lot.